is the environment. You used, Pong, part of Atari. Here, we are not using Atari, it's Mojoko, Half Cheetah, and you'll be able to see examples, easily by just even Googling it. Yeah. So
Right.
the environment is changing and it should be easier.
Right.
Secondly, what's changing obviously is the algorithm you need to implement. Previously, it was Q-learning based ones. Now it's reinforce and actor critic, advantage actor critic. That's what we mean by A to C, which we kind of covered during the class. So, and as Jong mentioned, it's continuous action space, and those are the only things changing. The others are logistics.
Right.
Any questions regarding programming assignment number 2, or is this straightforward?
I have a question actually.
Mm-hmm.
So when you grade, like, a lot of this stuff, like you professor mentioned, is like what is it? He said it's like dark magic. We have to like tune all like the
Yes, black
backslash,
magic. Yes.
yeah, that those parameters. So what if we get unlucky and like we couldn't get the right,
So
performance in there?
very good point. Very good point. So we'll try to be particularly generous in terms of this black magic. Starting programming assignment number 2. If your algorithm is perfectly correct, if it was just that your hyperparameters were off, and if you are not able to finish things in time due to wrong hyperparameter tuning, we will not be penalizing your final report too much. So we will be particularly more generous compared to programming assignment number 1 in terms of black magic, and also in order to make the training faster, or in order to make the development faster, definitely try to use GPU, as Jong mentioned. CPU training is slow, and using GPU will allow you to train many more parameters.
Okay. I have one more question. So like I know that in like the starter code we have some like libraries that have already been imported. Can we add some more if we want to?
Unless it is about the algorithm. I mean,
No, I'm not gonna add like probably like probably like if I was thinking of like using like kind of like grid search to do hyperparameter searching or something.
oh, I see. Yeah, you can take advantage of it. You can take advantage of it. So unless the library you are importing is part of your algorithm, it is fine. Yeah.
Okay, thank you.
But I should say hyperparameters can be a problem, but I should say it's so based on my experience, like it just damage your performance a little bit, but as long
The
as you
trend
have
should be, yeah, trend should be similar. Yeah.
right, as long as you have good algorithm and then good data set preparation, regardless of the like really weird hyperparameter, as long as you have reasonable hyperparameter, you should see the trend. So if you think that your algorithm, you don't see good reward, it's less likely the reason is hyperparameter. So maybe you try to look at your algorithm first, inspect it very detailed, and then maybe move to a hyperparameter if you have problem, I think.
And Jong, are we using the state vector or images?
For this state vector.
So shouldn't we add images?
Images.
I mean, use of the images for the training. I mean, just like what we did in programming assignment number 1.
Okay.
I mean, state vector, yeah, they are more or less guaranteed to work. Images become much more challenging. You are almost forced to use GPUs. And we can make, we can make the students to implement the image version of one of these 2 algorithms. Maybe not both, one of these 2.
Okay. Yeah, it can make the assignment harder.
I mean, in some sense, it's more like a bonus point. If you can make this
You can-
work,
you can
you
have-
get a good amount of bonus point. If you cannot make it work, the algorithm is correct, so you should be fine.
Okay. Yeah, last semester, yeah, I rechecked, and then we were using state vector for
Yeah,
half
yeah,
theta
yeah,
as well.
yeah, yeah.
Um, yeah, I mean, like we
Okay,
can make
let's casually try. This is more like a bonus point.
sure. So we will add like bonus point for image utilization, right?
Yeah, yeah, yeah.
For both environment, or do you think half theta is good enough?
Half cheetah should be good enough. Yeah.
Yeah, inverted pendulum is
I mean, just
too
one
simple, right?
environment and one algorithm. Yeah. Since
Right.
this is more like a bonus point. Yeah.
Okay. Okay. Sounds good. So you wanna talk about the administrative stuff about the like deadline and
I mean, as everybody sees, the deadline is in 2 weeks. Um, I mean, sorry, we cannot really extend this too much because we have two more assignments remaining. So it should be 2 weeks. Hopefully this works. And in terms of the submission, yeah, as Jongwoo mentioned, try to follow his instructions, which is pretty much the same as he used for assignment number one.
hmm. And this time, we give like maximum 10 days after the deadline,
Oh,
right?
yes. Yeah. So there will only be 10 maximum days. I mean, because the semester is getting toward the end, we cannot really have this infinitely.
Right. So what I mean is, for 5 days, you get maximum minus 50 points, and then after this, after 10 days, you
Okay,
cannot submit.
this is a good figure. All right.
Yeah, you cannot submit the assignment. So because this will help the people, the student who submitted the assignments can get the feedback early and
Yeah,
then
yeah,
prepare the programming assignment 3 early.
yeah,
So yeah, let's move forward together.
yeah, yeah. So there will be a total of 3 assignments. There will be a total of 3 assignments, and this deadline is, and this penalty graph is due to that. And for those of you who are suffering, yeah, you can talk to me and we can figure out the solution.
And for your information, this semester is much more generous than the last year. So please try your best.
Yeah, I mean, Jongwoo is doing a good job preparing, the starter code and everything. So this should be like easier. I mean, well, Black Magic is another thing, but at least in terms of the coding, it should be easier. Okay, sounds good. Any questions? So then let me take over. Let me take over. Okay, so this is the rough agenda. As mentioned, program assignment number 2 is due in 2 weeks from today. And Jong will be releasing this programming assignment number 2 document via EdStem. So it will be released today and it will be due from 2 weeks. And then programming assignment number 3 will be due 2 weeks right after programming assignment number 2 due. Assignment 3 will be released right after number 2. I mean, assignment 3, frankly, will be easier in the sense that you now already became familiar with all the environments. So you'll have 2 weeks, and then there will be project presentation, final presentation on 5th. I don't know. This is TBD. And then there will be final project report due, which is also TBD, but around these dates. So that's the rough agenda. And today we are going to talk about the evolutionary strategies. Which is a simple concept and simple topic. Before we dive in, do you have any questions for the midterm? I can go over the midterm if you want to know more about this. How do I enlarge? Oh, okay, I'll just do it this way. Okay, so let me just very briefly go over the midterm questions. So hopefully everything was straightforward to you, particularly given that it's an open book. Let me just point out a few things which could have been tricky. So, I mean, this question number one is about behavioral cloning, and I mean, it's pretty straightforward. I mean, this is the general policy learning formulation of providing state action. And this one was about relating the fitted queue iteration with behavioral cloning, which are just based on state action data. I mean, which are both based on state action data and writing a pseudocode how to train. I mean, essentially implementing the behavioral cloning pseudocode. And Dagger, I mean, we covered this quite a bit. The main problem is the data distribution mismatch. And then this also we covered quite a bit, this multimodal distribution problem. And yeah, and this one, okay, this could have been slightly tricky because I'm asking you to implement on a one array version. So what is in the slides is two array version, keeping two arrays separately when computing the value function. Here is one array, so you should have just iteratively gone through these cells in the grid and then update everything at every time step. So you just need to do it in one array version. And then here's the state value function. I mean, essentially the Bellman optimality equation. So it's a Bellman equation for optimal policy. So yeah, it's an optimal policy. And this was about comparing the policy iteration and value iteration, which is a special case of generalized policy iteration. And Monte Carlo and TD, they are different, but you should have mentioned that TD becomes Monte Carlo if it's infinite step TD. And SASA Q learning, well, it's on policy versus off policy. And here, as I mentioned, yeah, TD1, I mean, this is about relating TD1 and step TD and Monte Carlo. So if we have TD1, it automatically becomes infinite step TD, and it automatically becomes Monte Carlo. That's the solution. And this is about the pseudocode for TD lambda expected SASA. So expected SASA should have been easy. Instead of using, I mean, if you have a Q learning equation, Q running TD equation, you just need to replace the maximum with the this expectation or summation over the policy. And TD lambda could have been slightly more complicated because in order to obtain TD lambda, you need to essentially iterate through all possible n-step TD and then set the target value based on all these n steps. I mean, if you know the TD lambda algorithm, yes, in order to do this, you need multiple n steps, and that's what's most important in this pseudocode. So here, this was about the online Q iteration, and we already discussed quite a bit what the two major problems should be: correlated samples and moving target. And yes, DQN addresses this with replay buffer and target network. And yeah, I mean, whether this actually causes any problem for fitted queue iteration, the answer is no, and you need to explain. Regarding policy gradient, this is about directly computing the gradient with respect to the policy function. So we are directly optimizing the parameters governing the policy function. And baseline, yeah, this was about the variance. And this was a tricky question. Essentially, I'm asking you to have a modified version of actor critic, where you actually don't have the critic in the TD way, but you simply run the policy and then average their returns, as a critic. And what's the name of this algorithm? Well, if we do such modification, we are going back to reinforce. So the name of the algorithm is reinforce. And the question is about comparing reinforce with ectocritic. So this was a slightly tricky question, but you should have gotten that I'm converting ectocritic back into reinforce.